All right, my geometry gurus of Mr. Moss's class. I am going to share with you this video with your 3.1. We're starting chapter 3.1 today, which is going to be Thursday the 13th, no, the 11th of November. And these guided notes that you see that are sitting in front of me here are in your Teams page up there, where you go to the general section and then you go to files, go to chapter 3, and then you'll see the guided notes thing there. I put it out an announcement on Monday as to where to also find them. I think I even gave you a link that you can click on. So go back in to week 13 and look at my announcement that I created, and then there's a couple links there for you to get started with all of the stuff too. So with that being said, we are starting a new chapter, which is called, and I'm going to scoot this down just a little bit, Rigid Transformations and Symmetry. Okay, first thing we're going to be talking about are called reflections. So here's our definition of reflections here. So what we want to do, it says here, reflection is a line that is a function that maps a point to its image such that, okay, here's the deal. If the point is on the line, then the image and preimage are the same point. Okay, so here's what we're talking about here. So we have a line here. Here's our image or our pre-image. And notice that this has a capital A. And then our new image, which it says that if it's in the same spot and the preimage and the same point are the same point. So now a new thing you got to pay attention to is this little thing up here, which we call a prime. So this is A prime. So this is our original image. This is our new image that's going to be happening. And we signify it by putting a little prime number or a slash there, or apostrophe, or whatever you want to call it to make that happen, okay? So with that being said, okay, now, here's the other part, that this is the most important one that we're going to be talking about a lot today, is if the point is not on the line that is perpendicular is the perpendicular bisector of the segment joining the 2 points. So what that means is, so here's our original point over here, and what we want to do is we want to make it so that it is, and as it said in here in the rule, that is perpendicular, okay? Means it's 90 degrees. And then we have this little slash here. Let's do it in a different color, okay? And notice if this distance is, what that means is equal to this distance over here. So if this side is, let's say, 1 inch, that means the distance from this line to point A prime is also going to be 1 inch. But the key thing is it being perpendicular, and the distance is the same from this point to this part, and then this part to the new image on this, and it's perpendicular for that whole thing. Okay, so with that being said, we're going to go down and we're going to look at least one of these, and then I'll let you try to practice on your own. If you, at another time, we can talk about it later if you choose to. All right, so we have these points. Let's look at this one here. So we have this little like Star Trek symbol of some kind of a triangle, and I'm going to highlight all these points just a little bit more, okay? And what we want to do is, it says use any ruler. I got a 3x5 card, and what I'm going to do is, now notice, a couple hints that I like to remember is, see, notice which point is the closest one to this line of reflection. The closest one is going to be W. So that means W is probably going to be on this side, and it's again going to be closest to the line, whereas Y is technically the furthest one away. Therefore, Y is going to be the furthest way on this side too, and then we do the same thing with X and Z. So what I'm going to do with my 3x5 card, I couldn't find a, whatever you want to call it, a ruler, and I'm going to kind of guesstimate a little bit here as to drawing. Notice that the thing here, so I'm going to do a dash line here. And I'm going to look at the distance here, and I'm going to say it's going to be about right there. I'm going to do the best I can. I'm going to call this one W prime. Then we do the same thing with X. We're going to go perpendicular again. And we're going to kind of guess a little bit. So we're talking about maybe one of these lines as we see it here. So we're going to go this way. So we'll draw it, a dash line here, and we'll put this as a X prime. Y we're going to look at here, which it looks like it's just about almost just a little more than 2 of these. So we're going to go a dash line, and we notice that's going to be perpendicular. So we're going to go here with a little bit here. So we're going to put our y prime here. So now we have our x prime and our w prime, which is here. So we're going to draw these together. And we're getting a general idea. I know it's not going to be exact, you guys, but you guys get the general idea about where we're at. And then this one's about 1 full length away. As we do our dash line here, we'll do it here. We'll put our C prime here. Okay. And what I do is I would just connect, and it's somewhat close, but not as good. My handwriting definitely is not. If I had a ruler, it would probably be a little bit easier to do. Okay. So again, same thing on this one here. If you wanted to, again, notice that C is the closest one. So that means C is probably going to be the closest one over here. So we'd sit there and look. It's about a little less than a full length. So we put a dot here, and we'll call this C prime. Okay. B is, again, we're going to kind of go here. And it looks like it's just a little over 2 away. So again, I forgot to draw my perpendicular line to this. Draw a perpendicular line just over 2. So we'll put our B prime here. Same thing with A. We're kind of guesstimating here. Looks like about 1, 2, 3, 4, just a little over 4 of them. We'll do a dash line here. So about 4 of them. 1, 2, 3, 4. We'll call this one A prime. And then we got D again, which is about 2 away. So we draw a dash line this way, do 2 of these this way, and we'll put D here. Okay, and then what do we do after this? We connect all the points, and we hope that it looks exactly like the one over there. Okay, does that make sense a little bit? So C is the closest, B closest. The distance has to be the same like we talked about up here. So I hope that gives you a general idea about that. So let's apply this now to some real live situations here. Okay, so here we have a pool table. And it says right here that we wanted this cue ball, if we hit it from over here, we want it to hit against this side A so that it'll go into B. So how do we know to do that? So this is how we do a little pool playing. So if you think about this, and you guys have your little apps that have games on it, stuff like that too, we want to make sure that we are able to play pool and beat our friends. So the point is, okay, so we're going to choose this line to be our line of reflection as we're doing up there, okay? So that means we need to know the distance from what we want to do here. So that we're kind of working backwards now. So we're going to go, so the distance from here to here is what we want to do. So we want to draw our B prime out here somewhere. So let's look at our distance. Let's kind of use our imaginary ruler here. And as you can see, that it's about 1, 2, 3, 4, 5 of them away. So we're going to do the same thing over here. So we're going to go 5 away here, and we're going to extend out that here with my little, so 1, 2, 3, 4, 5. So we'll put our point B here. So we do it out here. And we call this out here is going to be B prime. So now, this tells us where exactly we need to hit on this wall right here in order for it to go in here. So what we're going to do is we're going to take our cue ball, and we're going to draw a line from the cue ball to our point B prime that we just created. So the point of where we're going to need to hit the ball is right there. So we hit it there. It should technically go inside the B slot. Okay, pretty cool stuff on that one, okay? All right, you guys have all done miniature golf stuff before too, okay? It says right here, Omar is playing miniature golf at a local course because a wall is blocking his direct shot. He needs to bounce the ball off the wall W and hit the hole located at point H, which of these steps would be needed to determine where on the wall W Omar should hit. So again, this is our end result. So again, we want to know the distance from the wall the hole. So it looks like right here, if we look at my imaginary ruler here, we got 1, 2, 3. So that means we need to extend this out. How many over here? 1, 2, 3. And this would end up being my H prime if we did our dashed lines to make sure it looked nice and straight with the same distance. And then the next thing we do is where we head with the ball, we need to go to, from the ball, to the point that we just created, H, and the point of where we need to make contact on the wall is right there. Okay, pretty cool stuff, huh? All right, hope you guys can get the general idea about what we're doing with reflections in order to be able to make that happen. We're all good there. All righty, let's go ahead and go to the next page. Now we get to work with graphs that we normally would see. Let's fix this up here. Okay. Okay, so we have a quadrilateral. And what we need to do is we need to have vertices of these things. So our thing is there. And now it kind of doesn't show up very well in here at all. But we got this line of reflection where it says x is equal to 1. So x equal to 1 right here. So we have this line right here. So this is our line of reflection. So an interesting thing about this scenario, and we may only get through this one before we have to stop and then move on to the next stuff. So this might take a few steps to do this. Is that notice that point M is on the left and then point J, K, and L are on the right side. So in order to be able to reflect it across this red line that we were doing here, that means M is going to flip over to the right and then J, K, and L will flip onto the left side. Okay. So with that being said, let's start with M first because here we go. And how many units away, and we got to make sure it's perpendicular to it, how many units away from this red line are we have here? It's 1 unit. So that means we're going to go 1 unit this way, and we're going to go M prime there, okay? So do the same thing with J. J is only 1 unit to the right, so that means it needs to be 1 unit to the left, and we're going to call this J prime. So we're drawing lines that are perpendicular. K is 2 units away from going this direction, so we go 2 this way. That means we go 2 that way. We're going to call this K prime. And then we have L, which is only 1 unit away. On the right, that means we go 1 unit to the left, and we go L prime here. And then what would we do when we're done? We connect the dots, and we have our new image, okay? Sometimes in some of the questions, they'll ask you to even give the new coordinates of that whole thing too, okay? All right, looks like we might have time to finish up this one too. We can do this one together. Now, this one's a little different. We have here where our line of reflection is down here. Okay, now the chances are we probably won't be able to reflect everything down here because we probably don't have enough room on our graph to do it. Okay, but we can sure start. So here we go. Let's start with this one. L is 1 unit up, so that means we're going to go 1 unit down. So this will be my L prime. This one's how many units up? 1, 2, 3. That means we're going to go how many units down? 1, 2. Well, can I kind of guesstimate? We'll call this one M prime. J is 1, 2, 3, 4, 5. So we got 1, 2, 3, 4, 5. So we'll call this one J prime down here. And then we have K, which is 1, 2, 3, 4. We go down 1, 2, 3, 4. And we hit that point there, and we'll call this one K prime. Then what do? We connect dots, and that's what we got. Okay, cool stuff. All right, we're going to stop there at this point so we can pause and we can move on to part 2 of this whole thing because I only have 15 minutes per session on the thing I'm allowed to use with this. All right, see you guys in a few minutes.